With example 26, we have 2 times the square root of x cubed plus 4. So our inner function is going to be x cubed plus 4. We're taking the square root of that. We're charged with finding f prime of 0, so we're going to need to rewrite f of x so that we can better take the derivative. The 2 is a coefficient, it's going to stay right there. X cubed plus 4 is our inner function. We're taking the square root of that. We know from algebra class that the square root of a function is the same thing as the function raised to the 1/2 power, because this is x cubed plus 4 to the first power, and we're taking the square root, so there's an unwritten 2 right there inside the v of the radical. Now, example 26 looks a lot like example number 22 up the top of the page. We can perform the chain rule on it. So let's go ahead and do so. So f prime of x, 2 is a coefficient, so it's going to stay. Then we have an inner function, x cubed plus 4, to the 1/2 power. The outer function is the 1/2 power, something to the 1/2 power. So we're going to derive the outer function, which means the 1/2 is going to move out front, and our new exponent will be 1 less than that. 1 less than 1/2 is negative 1/2. All right, in other words, 1/2 minus 1 is negative 1/2. We derive the outer function, we keep the inner function, and then we derive the inner function. And the derivative of x cubed plus 4 is 3x squared. This is f prime of x. We need to plug in 0, but because we've got a negative exponent and a negative rational exponent, it may be best if we tried to simplify this expression before we plugged in 0. Well, what sticks out to you for starters? Hopefully it's the 2 times 1/2. They're going to wipe each other out. Which means we can rewrite this expression. We have 3x squared, which that's a positive exponent, and we have a negative exponent. We know that negative exponents can become positive if they're moved down into the denominator. So we have is 3x squared over the quantity x cubed plus 4 to the 1/2 power. And again, something to the 1/2 power, as we know from up top, is the same thing as the square root. So this is really 3x squared divided by the square root of x cubed plus 4. That's f prime of x. We're interested in f prime of 0. So for f prime of 0, we plug in 0, and we have 0 up top, right? 3 times 0 squared over the square root of 0 plus 4. So, what happens? Well, 0 in the numerator, square root of 4, which is 2 in the denominator, 0 divided by 2 is 0. And that will be our derivative's value at 0. With example 27, we have a situation where f and g are not put together yet. We have to find the derivative of their composition at x equals 1. So in other words, we want the derivative of this right here. The derivative of the composition of f of g of x, that's our classic chain rule. That's equal to the derivative of the outer function, keep the inner function, and then multiply by the derivative of the inner function. Excuse me. We're interested when x is equal to 1, which means what we're really looking for here is f prime of g of 1 times g prime of 1. Well, instead of putting this all together, let's just do the individual parts. We need g of 1. Let's figure out what g of 1 is. G of 1 means we plug 1 into our function. So we have 3 minus 1 cubed. 3 minus 1 is 2. Oops, that's off the screen. Sorry about that. So we see that 3 minus 1 is 2. So what we're really looking for here is f prime of 2 times g prime of 1. All right, well, let's get f prime of x. F prime of x, well, f of x is 3x squared. The derivative of 3x squared, we're getting used to this by now, that's 6x. So f prime of 2 will just be 6 times 2, or 12. So this is 12. I'll move this up slightly. As far as g prime of 1 is concerned, first we need g prime of x. Here's g of x, so g prime of x. 3 is a constant, it derives to 0. Then we have negative x cubed. That becomes negative 3x squared. We're interested in g prime of 1. If we plug in 1, that's going to be negative 3 times 1, or negative 3. So we end up with 12 times negative 3, or negative 36, as our final answer.